Hello, welcome you all. So in this video, we'll talk about bias and variance problem. So this bias and variance is also sometimes known as underfitting and overfitting problem. So let's look into the details. So as we can see in this graph, we have first graph where we are trying to fit a line over there. Right? Now, once we are trying to fit a line, and let's say it's a classification problem, so we can find like many greens, these two greens are in this side of the line, and you can say red are in this side of the line. So this is not a very good fit, right? Because the error is high in this case. So this particular problem is known as underfitting problem, or this is also known as high bias problem. Now, in another case, if we are trying to find out a curve which is take care all the points, right? So in that case, it will try to learn those patterns completely, or you can say mugging up those patterns. So whenever some new data will come, they will have very high error, right? So this particular problem is known as overfitting problem or high variance problem. Now, if we look into the middle curve, this is a really good curve. Whenever a new data will come, this will give a very good performance, or you can say minimal error. And this is known as good curve, or you can say this is a good compromise. So, in short, if a particular curve or a model have high bias, it means model is not trained well. Means you have high error, or you can say you will get high training error. If you have high variance problem, then you will get high testing error. And if you have good fit, you will get low training and low testing error. So our target is to find out a best fit for our problem. So now let's understand how to solve this. Right? So as we discussed, if you have not trained well, then algorithm has bias problem. Or in another case, if you have trained more, then it's overfitting and you will get variance problem. So let's take example here. So in this example, let's take first one. You have training set error is just 1, but your testing set or dev set error is 9. This is showing high variance problem because you have high testing set error. And in this particular scenario, this comes under overfitting problem. Now let's look into the second case. Here, training error itself very high. This is showing high bias problem, means your model is not trained well. Now in another case, let's say you have bias is high, and if you compare with the variance, or you can say depth set error, it is much higher. So this is high bias, high variance problem. Now let's look into the final case. Here your training set error is also low and depth set error is also low. So you can say this is low bias and low variance, and this is your good fit that we are looking for. So in this way, we are able to understand when it is a bias problem, when it is a variance problem. Or you can say when your model is overfit and when your model is underfit. So now if you have high bias problem, what we can do? How to solve this problem? So the very first thing, increase the model size, because it is possible that your particular application or the problem that you are trying to solve, and whatever model you have chosen is not enough to handle that complex problem. So the very first thing that we can do, increase the model size. So once we say increase the model size means increase the number of neurons and number of layers so that it can able to handle the complex problem. Another thing what we can do to solve high bias problem, modify input features based on the error analysis. So once you have high bias problem, definitely you can check out the errors. What kind of error is occurring? And based on that error, you can figure out which features is imposing that error or which features have high impact on that error. Then you work on that feature and you'll get a better result. Another thing what we can do, we can look into the regularization. So in the next video, we'll talk about in detail the regularization term. So you can reduce this regularizer, either L1 norm or L2 norm, that will also reduce the bias problem. Then at the end, what else we can do? We can modify the model architecture. So in Module 3 and 4, we will see different variety of architecture as well on the top of this simple neural network. Like once we are trying to solve a particular problem, we have to look into the architecture as well. Which architecture is suitable for our problem? So if you have high bias problem, just check your architecture is really you have chosen a correct architecture or not to solve the problem. So these are initial major points that will help you to reduce the bias problem. Now if you will get high variance in the at the time of training, then what you will do, first thing you need to add more training data because maybe you have very less amount of data and you have a big network. So you can say your network is trying to learn your data. Instead of training from the data, they try to mug up the data. And that cause high variance problem. When it got new data, it will have or it is not able to predict correctly. Right? Then add the regularizer. As I told in the next video, we'll talk about the detailed of regularizer. So we'll add L2 or L1 or dropout regularizer. Then there's another technique that is the early stopping. So before your model will go to the high variance, stop it in advance. That is early stopping technique. So we'll see this also in the next video. Then again we have to modify the architecture. Architecture in this sense, you can say if you have very simple problem and you are taking a very big architecture, then it's not a good idea. What you can do, you can take appropriate architecture to solve the problem. This will affect both bias and variance together. So in that way, you can solve high variance and high bias problem. Now, when you say how we can compare the performance of our system, so ultimately, in order to compare the performance, we are comparing with the human performance, human intelligence. So let's take one example. Suppose you have a healthcare problem. In that healthcare problem, you have a doctors, or you can say five doctors in a panel. And if those five doctors able to achieve 95% of the accuracy, in that case, you can say if your model is achieving 94.5, then your model is giving very good performance. So in those variety of cases, we will compare with the human level performance. Now let's understand when we cannot compare with the human level performance. Suppose I want to buy a new book from the Amazon. In that case, if I will ask to my friend, might be he has read few number of books, but Amazon have thousands of books. So the recommendation system from Amazon will give much better result than my what my friends is suggesting, because my friends have very limited knowledge of the books. So in that way, sometimes we are comparing with the human level performance, and sometimes we are saying the performance of the system is much better. Similarly, if you say I am predicting the stock price and someone want to do algorithmic trading, in that case also maybe humans are doing much better though than any algorithm. So that's the way you have to think when you have to compare with the human level performance, and you don't need to compare the human level performance. And based on that, you will divide is your model is underfit or overfit or it's a good model. Now, if you compare here, suppose human error is 1, right? And your training error is 8 and your deficit error is 10. Then what you will do? You will try to take care of this point because your training error is very high as compared to human. Now in second scenario, suppose your human error is 7.5 and your model error is just 8. So in that case, you have high deficit error, so you can focus on the variance. Now, in another case, let's say here, if your human performance is 1 and your training error is 0.7 and deficit error is 0.8, then it's a good fit, so you don't need to worry. So that's the way how you can look into the variance, how you can look into the bias. So if your training error is high, then it's a bias problem. If your valid testing error is high, it's a variance problem. Based on that, you will work on to solve high variance or high bias. So that's it for this video. We'll catch you in the next one. Thank you.